You've connected to Cisco Unplugged.
Hello, everyone, and welcome to Cisco Unplugged. I'm Dan Klamert, your host, and this week on episode 43, we're going to be talking about Wi-Fi 6E, SP, standard power, AFC, LPI, design recommendations, and I would like to welcome back a special, very special guest, the founder of our channel, actually, Darshan Patel. How are you doing, Darshan, today?
I'm doing well. Thank you. Thank you for having me, Dan.
Oh, thank you. Thanks for being here and for founding our channel. I appreciate that. It's been almost going on 2 years now, I think. So early next year. But before we get going and get into it, I just wanted to remind people that we do use Slido for questions. So if you do have questions, we typically answer those always via Slido or on the show live. So submit your questions via Slido. You'll see the link in the YouTube on the YouTube channel there under the notes or on the screen now. You can join the Slido, submit any questions throughout the show. And then as usual, we are streaming and recording this on YouTube. So you can always go back and watch this episode and many others at youtube.com/@getunplugged. Go out there, please like and subscribe, and you will be notified when we do go live with more great content. And then also that helps us reach more people with the channel. So thank you very much for that. So with that, let's get unplugged. So Darshan, let's talk a little bit about 6E, SP, AFC, and LPI. Oh my, what do all these acronyms stand for?
Sure. So when FCC announced about Wi-Fi 6E, and it's after 20 years, the entire new spectrum, 6 gigahertz. So they provided that different classes, an LPI, low power indoor, SP, or standard power. Those are the two that we have seen it. And especially that's where most of the access points and clients are going ahead and certified. So we will be talking more into and understand about how does a quick going into service provider and AFC. Let's take a quick look into an LPI. And with that, let me go ahead and talk more into it. So once we have that 6 gigahertz by FCC announced, it provided the Uni-5 to Uni-8 in real world 59 non-overlapping channels. Oh my, we haven't seen it before. And then in the real world, in enterprise, and most of our 80% of carpeted space can actually use 80 megahertz channel width in a real world scenarios, in most of the cases, with 14 non-overlapping channels. So let's take a step further and understand what you mean by it. And the step further is in enterprise segment, we have, so consider this is more about the conference room. One access point is there, 20 to 25 people sitting in that area and another 20 to 25 on other side of that conference room. And it's a mix of those devices. Maybe 70% are actually able to connect to 6 gigahertz. And those devices which are capable with the help of client steering on the WLAN configuration and client driver update. Those can be motivated to connect towards a much cleaner spectrum, much faster and higher throughput they can achieve, while it also provides the old clients that are capable of only 5 gigahertz connect to that, and both can take advantage of airtime and higher throughput. So that's a great thing. That's what the 6 gigahertz has provided. Now let's understand one of the other areas that we have at very high density. So for instance, in this auditorium room, we had 9136 omnidirectional, but that did not provide a proper cell size and proper coverage, and did not have the great capacity for our clients to provide at optimal performance. And we replaced that with the 9166 D1. Those are directional patch antenna, provide the small cell size. And that helped. The other areas that definitely can be used for the small size directional, as we know in some warehouses, we know in hallways, in a healthcare environment, and many more use cases. And all of them are going to operate on low power indoor all the way from Uni 5 to Uni 8. But wait, that's not over, right? We have our old, this is a stadium, and where we have 9130 stadium antenna, or also known as 9104, that provided great coverage for this kind of a high density areas. And we can use those patch antenna AP to provide an overlay coverage with 6 gigahertz. So that's great. LPI can be used everywhere indoors, right? The question going into it is more about how does it operate, right? The channel width. So FCC provided us the 3 dB more power every time we increase the channel width, but maximum power spectral density for EIRP is 5 dBm per megahertz, and the limitation of that of maximum TX power is 30 dBm. So in US, every time we increase our channel width and double it, we get the 3 dB more power, while it's better than the 5 gigahertz, right? That was having a 3 dB noise floor increase every time we were getting a higher channel width. So in a real world, we can use that 80 megahertz, but can we utilize everywhere? And are those real, right? That's what we need to understand further. So we took out our survey gears and trying to figure it out. Like 6 gigahertz that is operating on the 20 megahertz channel width, the cell size was observed with 30 meters. So all your beacon power, all your management traffic, always being transmitted at the primary channel, even when you go ahead and have the channel width double or triple, or all the way till 160 megahertz. So all your data frame, that can be at 160, but your management traffic and beacon is limited to the cell size of 18 dBm. Let that sink in, right? Your 18 dBm is the maximum where the cell size is determined. But we question, is that enough? So we have enormous anonymized data of information about where that all information is there. So we have the transmission power. What we have observed is between 11 to 15 dBm on 5 gigahertz in most of the carpeted space that we have it. And in order to provide the same or equal size in 6 gigahertz, we have to increase that 2 or 3 dBm because of higher attenuation in 6 gigahertz. So with the 18 dBm of maximum EIRP, 6 gigahertz in LPI covers more than 80% of those use cases in carpeted space. So all our indoors is covered? Well, not all of it. Some are there that we need to take care, like atriums, right? Or high ceilings that we need to provide. How are we going to take care of it? Well, hold that thought. So this is for understanding about what do we have. So indoor access points are listed on the left, and all of those operate on LPI mode, low power indoor. And it can operate in a standard power with the help of external GNSS module or called GPS module. We'll talk quickly about how it can work and who is the central body, AFC, that can help us operate on standard power. And
Hey,
on
Darshan?
Yes.
Real quick, we have a question already here around, and I think it's a really good question around Wi-Fi 7. And I know we're talking 6E here, but this is, I think, a timely question. It's asking about how does Wi-Fi 7 change, if it does change any of this. And their company is looking to install APs here soon. And how should I take this? Or I wanted to know if I should take this into consideration. And I know, 7 still uses 6 gigahertz. I know it brings some new features like MLO and things along those lines, but just wanted to get your thoughts on that.
Certainly. So Wi-Fi 7 is definitely based on all of our great 2.4, 5, and 6.
Yeah.
So nothing is going to stop us making the use of that 6 gigahertz. What advantage that is going to provide is it all depends upon the clients. What is the percentage of clients that in the industry or vertical that you are serving? So what we have seen so far in higher education, I can talk about the numbers of 6 gigahertz client capable are in 30s. And I have seen Apple iPhone, even Pixel, those devices are being announced, iPhone 16s, all models of it, Pixel devices, the genuine one. And I'm excited about the Samsung devices as well. All that can support Wi-Fi 7. So that device support is going to continue to motivate us to further down the line deploy Wi-Fi 7. So Wi-Fi 7, I can generally see that it is going to be tremendous and very important going forward in 6 to 9 months. As we know, the new gifts are going to be there on a Christmas bucket list, and that is going to help.
Yeah, thank you. That's great. And one other question just came in while we were answering that one is around the GPS. And I think we're going to get to this when we talk about AFC, but it's a question around why do I need a GPS if I'm indoor, and how do I get a signal indoor?
Certainly. And that's where we are going to talk about it. If we are indoor, we can utilize that GPS module. And we are going to talk just in a few minutes going into AFC and how to utilize that GPS module. And we do not need on all of our access points to have that GPS or GNSS module, and can still operate on standard power if needed. So stay tuned. Just in a few minutes, we will talk about it. And if you still have more questions, we will come back.
Sounds good. Thanks, Darshan.
So on the right-hand side, as we can see over there, we have an outdoor access point, 9163E, and that is designed for standard power. And it can only operate on standard power. It cannot operate on low power indoor. So hold that thought about indoor access points, primarily designed for LPI mode, and then it can operate on standard power with the help of external GPS module or GNSS module. Now let's talk about the 6 gigahertz standard power, right? We saw the limitations over there, that it can have a maximum of 18 dBm of our beacon and management frames. So what about those high ceiling areas or even loading docks where we require more coverage and it does not have a high density, but low clients, and we do not want to go ahead and place it on walls and just directly point it. So how to attain more cell coverage? Well, that's where our standard power comes into the picture. And it can operate in Uni-Fi and Uni-7. So let's take a look over here where 400 or 500 people gather for an event trying to provide and have services. Obviously, our 9104 is great that it can provide the coverage in 2.4 and dual 5 gigahertz. But do we think 6 gigahertz is going to help, right? Definitely, it's going to offload that traffic. But can we use those indoor access points here in LPI mode? Let's wait. How about stadiums? Before, I definitely remember utilizing 2800 or 2Es and even external access points with directional patch antenna with over here as a NEMA box, or through the rails that we can put an external box and cover it to provide 5 gigahertz services in stadiums and many other high density area. So LPI, low power indoor, according to FCC rules, we cannot operate outside. Now, we cannot. And there are no external antennas that we can connect to our indoor access points. There is not there. We cannot use any weatherized enclosure like NEMA box or any of it. And then the question comes around, but there are many use cases like warehouses, atriums, lecture halls that still require services. So the way that I understood is low power indoor is like a table tennis. you can play table tennis and have your table tennis in your garage or in your media room. But I haven't seen people taking that table tennis in the backyard and can play table tennis all seasons, neither in front yard. They can have it in warehouses and can play it. So LPI is, for my memory to remember, is table tennis. We can always play it indoors and have it indoors to provide services. So standard power, what it can provide. So as we looked into before, LPI rule for maximum power spectral density is 5 dBm per megahertz. And the standard power changed that to 23 for all the channel width. It provides higher power limits and also provides external antennas that we can use it. So our 9163 can operate on a standard power. So what is standard power? So for my memory, I said standard power is like my swimming pool. I can have it outside, I can use it, and we can have it indoors as well, like in Olympics, and we can utilize it. So standard power is like swimming pool. That helped me remember things. Now, let's talk about, we talked about how it can provide. So in standard power, provides us the capability of creating a larger cell size. So we tested again with our 9166i now on standard power and with the help of AFC, which provided us a 27 dBm. And we saw that improvement of more than 40% of the cell size coverage with the same AP. And it is definitely going to be helpful in high ceiling areas, loading docks, lecture halls, stairwells, and more. So we can use our indoor 9166Is in a standard power as long as they are indoors, not outside, as long as they are indoors. So, okay, we want to use 6 gigahertz in standard power. And that standard power is actually utilized of 6 gigahertz as previously being used by other licensed users. And that has been licensed and have that database information in a standard body called AFC. So that administrator have all that information, which are the radios that is broadcasting in a given location at a given time. Those 6 gigahertz radios are being utilized. So we do not want to be like 5 gigahertz where radar is being detected, and after radar being detected, AP and clients not able to connect. So that was more about the reactive approach. We have improved in it, but it was a reactive approach. So in order to utilize 6 gigahertz, what we did, we formed an automatic frequency coordination. And that automatic frequency coordination has already existing licensed users, and licensed user radios are being known to that database. Now Wi-Fi came into the picture, and Wi-Fi said that how could we all coexist and utilize those channel width and power that we are not using it. So we can utilize AFC request every 24 hours, your AP can go ahead and send it out. So in a given area, when a licensed radio is broadcasting, we do not want to interfere. And in order to get the right amount of channel width and power, we have to request every 24 hours. And how do we get that location information? 9163, our outdoor AP, already has an inbuilt GNSS module. While we can have that external GPS USB module for our indoor APs that can be connected and use it. One caveat over here is, as height uncertainty is the number one reason when we see that APs are not operating on standard power, even after connecting that external GNSS or GPS module. So it is very important to have that information. And we will walk through that configuration as well. So AFC can be derived location over the air. So if there are, consider that you have the entire floor and you want to utilize that GPS module, put those APs in 4 corners. As long as their NDP messages are being heard on an RSSI, they can provide that information and they can still operate on standard power as well. But as that signal or uncertainty increases, your channel width and the number of channels and the power will continue to reduce. Wait, that is not only way. There is another way. If your APs are on the same switch and the same switch stack, not all APs requires that GNSS module. Maybe only 2 or 4 on a given floor, which are connected all across the corners of that office. And the rest of that are connected to a same switch stack, but maximum of 200 meters from each other. They can have a zone of uncertainty. And as we know that, the larger the area of uncertainty, you get lower channel width and the lower power. So try to use in those 200 meter and can still take an advantage of it. So in Catalyst, we use the CDP and LLDP is going to be there. And in Meraki mode or in cloud mode, we can use LLDP.
Okay, so in summary on that last question then, just to make sure I'm understanding this correctly. So with 6E, we introduced 6 gigahertz and beyond 6E. And since that's a spectrum that is also being shared by licensed users, when we switch from, so LPI, we don't need to worry about the indoor modules or GPS modules, but with standard power, we need to use or leverage AFC, which uses your location. So that's where the GPS module comes in and allows you to use the proper 6 gigahertz spectrum based on your location. Yep.
That is absolutely right.
The AFC is a central coordination service that is making sure that you're not stepping on other licensed 6 gigahertz spectrum effectively.
That is correct. So we have to be kind enough to know that, hey, there is a standard body. We do not want to step over you for existing 6 gigahertz radios. And for that, there is an AFC core standard body that has been formed.
Okay.
To provide that service.
There's another question here on AFC. It's about how does the controller talk to or connect to AFC? Will it be via the management interface? Do I need open ports on the firewall, or can I use dashboard for this? That's a good question as well.
So under 1712 and above and 1715 and above, we do not need to make any configuration change as long as there is a proxy being configured on it. And that proxy can talk directly from 9800 cloud proxy service to AFC system. So we do not need to make any configuration in the background.
Okay, thank you. That's great. And then one last point, I think it's a question, and I think it's a very important one. And I know you covered it somewhat, but I just want to be very clear on this. As far as the question is, I'm installing APs today in enclosures from Home Depot, outdoor, rated enclosures from Home Depot. Does this mean that does 6E mean that I'm not going to be able to do this moving forward?
That is correct. We cannot use our indoor low power indoor access point, put in an enclosure and use it outside. It is against FCC rule.
Okay. Yep. Thank you for clarifying. All right.
So moving on to and trying to understand our client system. So with our iPhone 16, as we talked about it, and all other great products that we have from Samsung, Broadcom, Qualcomm, chipset, more and more clients that we are seeing, those are dual mode clients. Dual mode clients, it means that they can operate both on LPI mode, your indoor, and when they step out for standard power, they can still remain connected as well. That's what the purpose of dual mode client. Dual mode AP for outdoor is not there. 9163 can only operate in a standard power. It cannot be converted to LPI mode. Now, one of our customer wanted to provide that services, generally services in a higher education, when they have, and more than hundreds and hundreds students gather every Tuesday morning to have conversation with the staff, what new things are coming in, and how can they participate. So they wanted to provide that extra connectivity and better coverage. In order to provide that, not only 2.4 and 5 that they were using before, now they moved on to our 9163E with omnidirectional because they wanted to have more than one area to be covered instead of patch antenna. But if we want only a directional patch antenna, we can utilize with 9163E as well. And they found it that not only during those events, it is also providing services when the class changes and moving from a building to building. And either they are on their TikTok or either they are checking how to go from one building to another building with the help of wayfinding. This outdoor access point has helped them to generally utilize and remain connected throughout the campus. With that being said, let's jump on to understand about configuration. And the configuration that we have it, the first and the foremost thing that we want to remember is that external GNSS or GPS module that we have it, that needs to be enabled. So that external USB port that we have it, we have to go ahead and have that AP joint profile USB enabled. And after that, go ahead and check your RF profile. So we have to create an RF profile for our standard power. That standard power is being used on an AFC. So we have to enable that standard power. Now, after doing that, we need to apply that to an RF tag. And that RF tag, once we apply that on RF tag, that needs to be applied on an AP. Once we apply that on APs that we are going to do it, there's only two things left, right? The configuration that we require for all APs is to go ahead and check that height and height uncertainty information that we need to apply. It is very important to know that AFC standard coordination, to know that at what height you are, and more uncertainty increases, it is able to provide less and less power to operate. Now, once we do that, the way that we can monitor is through checking on our AFC, check the configuration, what it is asking for. Over here, we get what are the requests that are being sent out and received. And on top of that, we can also find additional information. As we can see, our 9166i can have the liberty to operate on standard power or LPI with the help of USB module. Currently, it is operating on standard power. And our 9163E, which is directional, can be operate only on standard power, as we can see over here. Well, it is the similar configuration that we have it on the Meraki side as well. So under the cloud configuration, go into the 6 gigahertz, enable that GNSS. We need to go ahead and enable our AFC and standard power, set the height and height of access points. And after that, we need to have that accuracy range, similar what we saw on on-prem wireless controller. And then we need to apply to APs. One thing that we need to, before we complete, let's take a look into what is the most important things that we learn. So indoor APs cannot be used outside, period. Indoor APs can operate in LPI mode that we talked about that can be used inside. And certain areas with a large cell size that we require We can have our indoor APs like 9166Is can operate with the help of standard power, with the help of external GNSS module. Outdoor APs is like an standard, cannot be used in LPI mode. So a 9163E or 9167E cannot be used in LPI mode. While outdoor APs can only be used in standard power mode, but they can be used outdoors and indoors. Last and the most important, AFC is not a replacement of RRM or auto RF or AI RRM. It's a central federation providing channel width, and power for standard power access points to operate 6 gigahertz outside and inside where needed. Thank you.
All right. That was a great overview. Love that last slide, hitting home on those important points. I don't see any other questions. There is a question around roadmap, which I don't think we can really address on here, but it's around the question of wall plate APs, looking for a 6 gigahertz wall plate AP. I guess I'll just say that if you look at our history or pattern, we've skipped every generation. So I guess stay tuned on that for upcoming announcements. Anything else, Darshan, do you want to talk about today, or?
I think I'm all
great.
set. I just wanted to say thank you, everyone, and stay tuned. And we are soon going to talk about more about what does MLO and Wi-Fi 7 is going to be in a matter of few weeks. Thank you.
Yeah, awesome. Yeah, thanks, Darshan. Great episode. Love learning a lot more about 6 gigahertz, standard power, AFC, and everything else we discussed. We got some great questions. Thanks for those. I don't see any others, but thanks again for tuning in this week. Again, as a reminder, please subscribe to our YouTube channel, youtube.com/@getunplugged. Like and subscribe. And like I mentioned, it helps us reach more people. It helps you get notified when we post more great content, like some of the announcements that Darshan just alluded to here that are forthcoming. And if you do have questions, you can always reach out to your Cisco account teams. You can reach out to us at getunplugged@cisco.com. You can reach us on X, Twitter at Unplugged80211 or on Threads at Unplugged Connectivity. All right. Thanks a lot. It was a great episode 43 in the books. Appreciate everyone watching. And until next time, stay connected and unplugged.